Okay, so we are doing the acceleration notes, and this is just going to be what you get to use on your test. It's going to have the vocabulary, the variables, the units, and it's going to have practice math problems. So you definitely want to make sure you take this. Don't skip out on it because you can use this on your test. Okay, so I just titled mine acceleration notes. My date is 11/12. I'm only on page 3 because I don't use my notebook all the time like you guys do. So you'll be further in. So let's just start with the definition. So acceleration is the change in velocity over the change in time. So we're going to say change in velocity over change in time. And remember, this is a video, so you can pause it if you feel like it's too fast for you to keep up. Okay, so we're going to talk about the equation first. So I've given you the equation before. Of course, I break my pencil, right? Oh, there we go. I've given you the equation before, but we want to have it in one spot so we can just make sure it's easily accessed. So we know that it's the change in velocity over change in time. So we're going to start with acceleration equals delta V over delta T. And remember, the delta, the triangle, means change in. So I'm going to put that here. Triangle equals delta, which equals change in. So the change in velocity over the change in time. So we also use a little formula for that on the top. So to get the change in velocity, we need the difference in velocity. So we need to know what it started at and what it finished at, and then we have to make a subtraction problem. So we would also say acceleration equals VF, which is final velocity, minus VI, which is initial velocity, over time, which is T. And we could say TF minus TI, but most of the time we start at 0 seconds and work our way to however many seconds it is. So if we went from 0 to 5 seconds, that would be 5 seconds of time. So I don't very often say, oh, we're starting at 3 seconds and going to 8 seconds. Then you'd have to do a subtraction problem. Okay, so just remember, sometimes you do have to do that, but very rarely. Most of the time the time is reported already in seconds that we want you to use. Okay, so let's talk about the variables. So remember, the variables are the letters that represent the terms that you're using. So in this case, capital A is going to be acceleration. VF is final velocity. VI is initial velocity. And T is time. So this time we have 4 variables we have to worry about. Instead of velocity that only had 3, we have 4. So when we're writing out problems, you're going to see me using those 4. Oops, sorry, I couldn't see it there. Using these 4 variables. So A for acceleration, VF for final velocity, VI for initial velocity, and T for time. So let's talk about the units as well. So each of those have the standard units. Now remember, units can vary, but the standard units are the ones that we use on standard equations for every term will have a standard unit. So for acceleration, it's going to be a meters per second squared. For final velocity, a meters per second because it's a velocity. For initial velocity, a meters per second because again, it is a velocity. And time is going to be in seconds. So notice my seconds here of time match my seconds in my meters per second and my meters per second squared. So that's important for our standard units to always match as well. So we have already talked about positive and negative accelerations, and we wrote some notes about that before. So it's really important that you remember that acceleration can be both positive and negative. So I'm going to write that down just as a reminder. So acceleration can be both positive, or I'm going to change that up. I'm going to say positive or negative because I don't want to say both positive and negative. It sounds like it could be that at the same time. It can be positive or negative. So direction matters. So if an acceleration is going to the right, it's positive. Acceleration is going to the left, it's negative. If the object is slowing down or speeding up, all depends on the velocity's direction as well. So that's just something to remember. We did posters on that, so you definitely should have that nailed in your head. But remember that direction matters, okay? So sometimes we're going to be looking for other variables in this equation. Now, I do not want to, so this is the equation here. I do not want to have the algebra done every time. There's no circle like we've had before that goes with all of this. So instead of having you do the algebra, I'm going to give you the other equations in case we're looking for some of the other variables. So this is going to be the final velocity equation. So what happens if we're searching for the final velocity? So how that might work is I might say, okay, an object is traveling at 3 meters per second. It accelerates at 1.5 meters per second squared for 6 seconds. What is its final velocity? So I want to know what the velocity ends at after it's accelerated over a certain amount of time. So if that's the case, we would be looking for VF. So VF is what we're going to be searching for. So it's going to be final velocity equals my initial velocity plus acceleration multiplied by time. So I'm going to take my acceleration and multiply it by time first because I have to do my PEMDAS, right? So multiplication comes before addition, and then I'm going to add my initial velocity, and that should give me my final velocity. Okay? So that's the final velocity equation. So one thing I want you to remember is if an object starts from a stop, then initial velocity, which is VI, equals 0. Let's turn this into a colon so don't get confused like a negative sign or something. Okay, so VI equals 0. So an example of that would be a car is at a stoplight, and when the stoplight turns green, they accelerate at 4 meters per second for 6 seconds. What is the final velocity? So in that case, I didn't give you an initial velocity, but you have to remember I said that the car was at a stoplight. So that means that the initial velocity would be 0, and we would not be adding anything in this case. So we just do acceleration times time plus 0, and that would give us our final velocity. Okay, so there's also an initial velocity equation, which is very similar to final velocity. Initial velocity equation. So this one is going to be VI equals, so we're going to be searching for VI. Move it up a little bit for you. And that's going to be our final velocity minus acceleration multiplied by time. So in this case, you'd still multiply first, and then you'd take whatever your final velocity is and subtract that number, and that will give us what our initial velocity was. So a situation like that might be, I accelerated at 15 meters per second for 3 seconds. And my final velocity was 25 meters per second. What was my initial velocity? So I'll give you the final acceleration and time, and you have to find initial. But do remember, if an object comes to a stop, so maybe I didn't give you a final velocity, but I said the object stopped or came to a stop. So you were slowing down to come to a stop at a stop sign or a stoplight. So if an object comes to a stop, we'll do a colon, then our final velocity is going to equal 0. So just remember, in a story problem, look for those words, either starting from a stop or coming to a stop. That means our final velocity is 0. In the case of starting from a stop, our initial velocity is 0. Okay, so I'm going to turn the page and do some examples with you of how to solve these story problems. So I've given you multiple equations, okay? And we are going to now move on to finding some of these, okay? So let's start with some examples. Oops, I'm going to move the camera back up to the top. I'm going to just title it examples. So the first one, find the acceleration of an object. Find the acceleration. Wow, I keep breaking my pencil. Of an object that starts at 5 meters per second and goes to 22 meters per second in 6 seconds. So I'm going to do what I do in all my problems. I'm going to underline what they give me and circle what I need. So it says find the acceleration. So that's what I need. So now I know I'm looking and I'm using the acceleration equation of an object that starts at 5 meters per second. So that's my initial velocity because it says starts at. It goes to 22 meters per second. That's my final velocity in 6 seconds. That's my time. So I'm going to write out my equation variables. So A, VF, VI, and T. So my acceleration is what I'm looking for. That's going to be my X. I know my units, but I'm going to look. I have a meters per second and my time is in a second. That means I'm going to find mine in a meters per second squared. My final velocity is going to be what they end at. So it's going to be 22 meters per second. My initial velocity is going to be 5 meters per second. And my time is going to be 6 seconds. So this point, I'm ready to plug it into my equation. Since I'm looking for acceleration, I'm going to use the base equation of acceleration equals VF minus VI over T. Sorry, sometimes I write my A's like this and sometimes like this. Most of the time I do it like this, but it's larger, so consider it capital A still. But technically that's the best. Just got to remember to do it. Okay, so VF minus VI over T. So VF, I'm going to plug it in. So acceleration first, we'll start there, is x meters per second squared. Now I do my VF, 22 meters per second, minus my VI, 5 meters per second, divided by my time of 6 seconds. So in this case, I need to solve with my everything on top first and then deal with the division after. So you always solve everything on top of the equation and on the bottom of the equation before you do the division. So I'm going to plug it into my calculator just to be sure. You could do that in your head, 22 minus 5. That one, and then I'll do the calculator for the division. So 22 minus 5 is 17. And my units carry over. It's a meters per second. Okay. Now I'm going to move over my 6 seconds because there's nothing to solve on the bottom. Now I'm ready to divide. 17 divided by 6. So this is where I'll plug it into my calculator. And I get 2.8 with 3 years repeating. So I'm just going to go out and leave it at 2.8. And so my answer is going to be 2.8. And if you notice, it's a meters per second divided by another second. So it's going to be a meters per second per second, which is what we call a meters per second squared. So that's how we get that. It's a meters per second per second. So since this meter is on top and the second is on bottom, and then there's another second, with this second being on the bottom and then this second being below it on the bottom of the total equation, you cannot cancel. Okay, so a lot of people go, well, what can't you cancel since there's an S on top and an S on the bottom? No, because this is it's a division basically in itself over top of another S. So you cannot cancel them, so it becomes a meters per second or a meters per second squared. And that is our answer. All right, number 2. What is the final velocity of a ball that accelerates at 25 meters per second squared over 16 seconds if it starts from a stop? Okay, so what is the final velocity of a ball that accelerates at 25 meters per second squared over 16 seconds if it starts from a stop? It's going to be a really fast ball, you guys. Most likely it had to have been shot out of something like a cannon. Okay, so what is the final velocity? And that's what we're looking for, so I'm going to circle it. It accelerates at 25 meters per second squared over 16 seconds. If it starts from a stop, this is important. I didn't get any information, but it started from a stop. So that did tell me that the initial velocity is going to be 0. So let's go ahead and write out our A, VF, VI, and T. See, I went back to my old A. Had it there. Okay, so acceleration is given to me, 25 meters per second squared. Final velocity is not given to me. It's what I'm looking for. So that's going to be x. And since I have a meters per second squared, I'm going to have a meters per second for my velocity. My initial velocity is given in this form of a sentence that says starts from a stop. So it's 0. And my time is 16 seconds. It gave it to me there. So I'm going to use the equation for initial velocity. Final velocity. So that's going to be the final velocity equals my VI, my initial velocity, plus A times T. So let's plug it in exactly into this equation. So VF is going to be x meters per second equals my VI, 0, plus my acceleration, 25 meters per second squared, times, because I'm multiplying, my time, which is 16 seconds, equals. So now I need to figure out by doing orders of operation. I need to multiply before I add. Luckily, this is a 0, so I won't be adding anything, but I just need to multiply 25 by 16. So 25 25 times, there we go, 16 equals 400. Now we know that it is a meters per second. That's saying it was ended at 400 meters per second. That's so fast. So let's talk about the units really quickly on how did we get from a meters per second squared times a second to get a meters per second. So let's break down what a meters per second is again. Remember, it's a meters per second per second. And then we're multiplying that by a second. And anytime you multiply something that's individual, you can always put it over 1 just for the sake of saying it's a fraction, and so we can actually do the multiplication. So our second on the bottom down here now is available to cancel because of the fact that we now have a multiplication of a second on the top of an equation. So those 2 seconds will cancel. That leaves just a meters per second times nothing because we canceled out that second, which means the 1 doesn't matter. And therefore, that's what we're left with here, which is a meters per second. So that's how we go from multiplying acceleration and a time to get a velocity unit. All right, let's do another example really quickly. So number 3, what is the initial velocity? You guys hear screaming? I'm in my classroom and the window's open and it just started pouring down rain, like dumping, and the PE kids were screaming as they were running in. So what is the initial velocity of a car that is accelerating at 2 meters per second squared over 4 seconds if it ends at 10 meters per second? So now I'm looking for initial velocity. So what is the initial velocity? So the starting velocity of a car. So they're giving me the acceleration of 2 meters per second squared, the time of 4 seconds, and a final velocity of 10 meters per second. So I'm going to use all of my variables again. Now it doesn't matter what order I put these variables in when I'm just listing them like this. I could do it in any order, but I always like to do it kind of in order of how the original problem goes. So acceleration, final velocity, initial velocity, and time. Acceleration is given to me at 2 meters per second squared. My final velocity is the ending velocity at 10 meters per second. My initial velocity is what I'm looking for. So it's going to be x meters per second, the starting velocity. And my time is 4 seconds. Okay, so now I'm going to use the equation VI equals, because we're looking for initial velocity, my final velocity minus acceleration multiplied by time. So I'm going to plug it in, take these and plug them into these variables. So if I'm looking for VI, it's going to be x meters per second equals my final velocity, which is 10 meters per second, minus my acceleration, 2 meters per second squared, multiplied by my time of 4 seconds. So orders of operation say multiply before you do the subtraction. So 2 times 4 is going to be 8 meters per second squared times a second. Remember that whole thing, how we got rid of that? But I leave it in there now until we can start canceling. And then I have to carry down my 10 meters per second so I can do the subtraction. And I'm going to now cancel out. This second cancels out with the squared part of this. So now I have a 10 meters per second minus an 8 meters per second, which means that I can do the subtraction, because remember, you can only subtract and add like terms. So I have a meters per second and a meters per second now, and they can be subtracted. So now I know 10 minus 8 is 2 meters per second. And that is the initial velocity of the car. So it was going 2 meters per second. It accelerated for 4 seconds and ended at 10 meters per second. Okay, so those are the examples for the 3 equations. And I wanted to really quickly show you guys one other equation. Let me just check and see if I put it in the other video. So I did not. So it's okay. And we don't need it because we're not actually going to do it. But if we do need it in the future, I will add it to our notes separately in class. So right now we'll just stop at that and just make sure you keep that in your notebook so you can have it for your test. All right.